Hey girls, in our lesson yesterday, what we learned about was simplifying radicals, but every single answer turned out to be perfect squares or perfect cubes, and all of our radicals canceled out. They all ended up in perfect groups of 2 or groups of 3. There were never any extra leftover factors that didn't pair up with something, whereas today, we're going to have some leftover factors. These are not perfect squares. They're not perfect cubes. Let's talk about how to simplify them. So first, let's just start with a couple square roots, like the square root of 80. You should know 80 is not a perfect square. So you're going to start it out the same way we did yesterday with the factor tree. So think of what factors can I multiply to 80. Maybe you do 8 and 10. You might use something different, but you'll end up with the same answer. Go ahead and follow along with me for now. Those are not the same numbers. 8 and 10 are not matching. So I'll break these down further to 4 and 2, 5 and 2. We got a factor pair there with my 2's. 5 is a prime number, so it can't break down anymore. But 4 is another perfect square that can break down into 2 times 2. So in order to rewrite this time, I have 2 squared, and 5. Each one is going to go under its own radical. So I have my 2 squared because I have a pair of 2's. 2 times 2 is 2 squared. This other pair of 2's can also be written as 2 squared, and then my 5 is left alone. Just like yesterday, we know that a square root and a square cancel each other out. So we end up with just 2 times square root 5. To multiply those back together, 2 times 2 to get 4, and bring down the square root of 5. Let's do another one that's a little harder. This time it has variables in it as well. So what you're going to do first is you're just going to ignore the variables and look at the number 32. 32 is not a perfect square, so you're going to start with a factor tree. 32 could break down into 16 times 2. 16 could break down into 4 times 4. I know 4 and 4 could break down further, but since it's already a factor pair, I'm going to leave it. 2 is a prime number, it's left alone. So instead of 32, I'm going to write square root of 4 squared, square root of 2. Now let's take a look at my r cubed. We know that r cubed really means r times r times r. So are there any matching factors? Yes, r and r are matching factors. So you could write that as r squared times r. So I'm going to write that as r squared times r. Go ahead and put that extra r in yellow also because it doesn't have a match. Next, let's focus on the k to the 4th. K to the 4th, what that really means is k times k times k times k. Are there any matching factors? Remember, since this is a square root, whenever the number is not written, that means it's a square root. We are looking of 2. This one has 2 groups of 2. You could write this as k squared times k squared. So that's what I'm going to do, k squared, k squared. Now let's move that out of the way. And next I'm going to focus on my t to the 5th. So t to the 5th, I know what that really means is t times t times t times t times t. I'm looking for groups of 2. I notice I have a group of 2 here, and another group of 2 here, and then I have this leftover t. I'm going to make it yellow again to match up with all my other leftovers. So that's t squared, and t. Okay, I need to move this out of the way. I'm running out of space here. I'm going to have to move this down. Okay, so I had t squared, and t. T squared from the orange, another t squared from the blue, and my leftover t in yellow. Anything that's a perfect square cancels out the square root. So that 4, the squared cancels out and the square root cancels out. The 2 cannot cancel the radical, so it's staying under the radical. This square root can cancel out with the squared and the green R. This k can cancel. That t, again, has to stay under the radical. Let's rearrange everything so that we have everything without a radical in the front and then anything with a radical in the end. Because we know the order of multiplication doesn't matter. So we can rearrange this. We'll make it 4. That's the square root canceled out. R has the square root canceled out. That blue k has the square root canceled out. My pink k has the square root canceled out. My orange t had the square root canceled out. My blue t had the square root canceled out. And then I have all my square roots. I have a 2, an r, and a t. This could not cancel out the square roots because they weren't perfect squares. So now to simplify my answer, instead of putting 4rkkt, I'm going to make this 4rk squared t squared, because k times k makes k squared, t times t makes t squared. And then under my radical, I'm going to just extend it and put this all together. 2rt. That's my final answer. On this problem, we expanded it all the way out. In the future, what you can do is this. You can just look for groups of 2. So once you deal with the number in the front, then you can look at this and say, okay, with r cubed, how many groups of 2 can I make? I divide 3 by 2. I get 1 with a remainder of 1. So notice on the outside of the radical, I have r to the first, and I have 1 remaining r under the radical. With my k to the 4th, how many groups of 2 can you make? You can make 2 groups of 2. So on the outside, I have k squared. There's no leftovers. That's why there's no k under the root. Last but not least, with t to the 5th, how many groups of 2 can you make out of 5 t's? You can make 2 groups of 2, and there's 1 t left over. So essentially, what you might want to start to recognize is that any leftover factors belong under the root. Any leftover factors without a pair or without a match or a perfect square. Okay, we're going to do one more example where we have a cube root instead of a square root. So take a look at this problem C. We have the cube root of 8, a to the 6th, b to the 7th. So on this one, I'm going to expand it out again, but I'm going to show you it a little bit differently because maybe this will click for some people if that last method did not make sense to you with expanding it all the way out. Maybe this will make more sense. So first, just look at the number, the cube root of 8. Hopefully you guys know that 8 is a perfect cube. It's 2 times 2 times 2. So if you wanted to, you could write 2 cubed under the cube root, cancel that out, or you can skip straight to the cube root of 8 is 2. Next, let's look at the a to the 6th. Remember, we're trying to figure out how many groups of 3 can you make. With a to the 6th, you could expand it out, make it a times a times a times a times a times a. How many groups of 3 can you make? You can make 2 groups of 3. So you could write this as a cubed under a cube root, a cubed under a cube root, and those will cancel out. The cube root and the cube cancel each other out. So we end up with just a times a, or a squared. The other way you could think about that is thinking, okay, a to the 6th, I know that's a squared cubed, because remember, a power to a power, you would multiply those together, you would get a to the 6th. That's the same thing. Put that under your cube root. The cube root and cube cancel out, you get a squared. So it works either way. Now with b to the 7th, this one we know we expanded it out. There's 1, 2 groups of 3, but then you have an extra b left over. So what you could do in this case is you can say it's the cube root of b squared cubed, because there's 2 groups of 3, but then you have an extra b left over. Remember on the last problem we said any extra factors that are left over that aren't perfect groups have to stay under the radical. So since this b doesn't have a group of 3, it gets left under the radical. This cube cancels out, so you have b squared, and you're left with the cube root of b that has to come down to your answer. If we are looking at it like the last problem, it's saying, okay, how many groups of 3 can you make out of 6? You can make 2 groups of 3. There's no a's left over. How many groups of 3 can you make out of 7? You can make 2 groups with 1 b left over. Right, there's a few practice problems that I want you to try. Go ahead and pause the video, try them now. And here are your answers to check your work. Last but not least, I want to do one last one where there's a number in the front. So let's say we wanted to simplify this 3 radical 80. We already found out that radical 80 was 4 square root of 5. We did that up here. So let's just repeat what we did there. 80, we made our factor tree. I think we did 8 and 10. Let's say we did a different one this time. Maybe we did 4 and 20. 20 is 4 times 5. I see a pair of 4s, and I have a 5 left over. Now you can't just forget about that 3. The 3 needs to come down. But then 80 I can split up into 4 squared times 5 under the radical, because 80 was under the radical. But then the 4, the squared and the radical cancel out. So the 4 actually ends up out of the radical because it was a perfect square. Finally, multiply the 3 and the 4 together to get 12 and bring down the radical 5. There's one last one for you to try. Here's the correct answer. That wraps up that lesson. Next, we're going to learn about multiplying radicals. I hope you learned a lot of simplifying them when they're not perfect radicals. You're going to need to know this stuff still for the lesson tomorrow. So if you have questions before we build on it, make sure you get those answered. Talk to you soon, guys. Hope you have a great rest of your day. Bye.